Science Beetle.
Hey, welcome back, students. Last time we left the discussion with answering the question, what is matter composed of? And we went down the line in the example that I provided. I shared the example of the human body. And in that example, I provided that the human body is a collection of systems. In fact, let me go ahead and write this down so that you can see the whole diagram. So essentially what I said was that the body was composed of systems, which are composed of organs, and these organs are composed of tissues. And tissues are essentially composed of cells that have a unified purpose. And these cells, if you go by and look at them individually, they're going to have a nucleus and organelles inside, and those are going to be like the lysosomes, the endoplasmic reticulums, and so forth. But if you look at the nucleus is going to be, on the inside, it's going to have DNA and a nucleosome. But the DNA, if you look at that a little bit closer, you're going to find out that it's composed of a nucleotides, 4 of them, a phosphate group, and a 5-carbon sugar. And here at this stage, any of these, the nucleotides, the phosphate groups, or the 5-carbon sugar, all of these, if you look a little bit closer, all of these are going to be composed of elements. And it's these elements then is what really is the focus of today's lesson. And so we're going to look at elements, and in particular what we're going to be asking here is going to be, are elements the final subdivision of matter? And I'll just be honest with you, the answer is no, it's not. You can go one more level, and so elements can be broken down even further, and if you find out that when you do that, what you find out is that elements are actually composed of atoms. And atoms, believe it or not, can actually be further broken down into smaller subatomic particles, and those are known as the protons, the neutrons, and and the electrons. So let me just rewrite neutrons here, it's kind of messy. So there you go. What I wanted to do is really focus on elements for this lesson. So let's go ahead and do that. So when we look at the elements, we also have to consider that there are over 100 elements. In fact, if you look at the periodic table, which is a tool that we get to use, there are there are 118 known elements that are in existence today. Now, before you start panicking, don't worry. You don't have to remember everything about 118 elements. It's just too much information to remember all at once. What I do want you to know, though, is that these 118 elements are going to be represented in something known as the periodic table. And so let me show you an example of a periodic table. So as you can see, here's an example of a periodic table, and what we've got here are going to be all kinds of elements that are identified, and in a later tutorial or a later lesson I'm going to be able to show you the different regions of the periodic table, and there's generally 3 general types of elements that we're really concerned with, or that are identified on the table, and those are going to be metals, nonmetals, and these things that we call metalloids. And I won't talk too much about them today, but do know that all of these things are identified on the table, and in general, and of course this is not going to include them all, this is just very general, the metals are going to be the elements roughly in this general ballpark, also including the ones at the bottom here. And I will go ahead and pause and show you the nonmetals. The nonmetals are going to be on this side roughly. Okay, and the metalloids, I'll choose a different color here, but the metalloids are going to be typically these right here that I've identified in blue. Okay, and so generally that's the periodic table. Now let's look a little bit closer as to what kind of information is on this table. First thing that you're going to notice is that the table is arranged in almost a column type format. So you see that you've got one column here, you got another one here, so on and so forth. And it kind of repeats all the way across different columns. Now I won't go ahead and draw them all, but essentially they're all identified in columns. And these elements down here at the bottom And let me make sure that I distinguish them from the others. These elements actually fit right here in these sections, right here. And so if you notice here carefully, and hopefully you can, the numbers are identified there, 57 through 70, which is going to be the top row here. And then the bottom section is 89. Sorry about that. The bottom section is going to be 89 to 102, and that's going to be the second section down here. And so as you read across this particular row here, you're going to make sure that you go from barium to the lanthanide series down here at the bottom, beginning with 57 all the way across to 70, and then you continue on with 71 there. The other item that you need to pay attention to is that there are gaps here in this example of the periodic table. Oh, I moved it again, so let me go ahead and move it back. I'm sorry. But what we've got here is we've got gaps here and here. And those gaps, got to keep in mind that 113 actually is there. So I'm going to write 113 here. And then you've got in this second gap, you've got 115 through 118 that are represented, or that should be there, but they're not represented in the table. One of the main advantages of the periodic table is it gives us a very easy reference guide for us to identify elements. Now, we can't go and identify every single one of them by memory. Well, some of us can, but most of us are not going to be able to, largely because there's just too many elements to remember. But over time, you're going to build this ability to recognize many of the elements. An easy way that the periodic table has kind of formed itself or has been developed to do is to give you a way to easily and quickly identify the element. And if you noticed here, what I'm going to do is I'm going to move the table up to shrink it down, move it over to the left. And so what I want to bring your attention to is if we take a look at this particular element here, let me go ahead and blow it up. So show you what it looks like over here. And so you've got this letter H in the middle, you've got a number that's attached to it up above. And at the bottom you've got a number of 0079. Depending on which periodic table you look at, the number could be 1.0079, or you can also find it as 1.008. So it's going to vary depending on the table you look at, but just keep in mind that they're the same thing. The only difference here is going to be that the 1.0079 has been rounded off to move the 9 over so that you can get the 1.8 or the 1.008. So we're just going to go ahead and stick with the 1.0079 for this example. And so what I want you to kind of look at here is kind of get some of the information that's off of this. This here is essentially the symbol that we're given to be able to readily identify the particular element. Every single element identified on the periodic table is going to have its own unique symbol. And the other thing about this is that the periodic table also gives you two numbers, the number at the top and the number at the bottom. The number at the top is going to be the atomic number. So let me write that here, atomic number. This also happens to be the same thing as the number of protons that are associated with that particular element's atoms. And then the number at the bottom is going to be the mass number. And the mass number is essentially the mass of the entire atom. And so this mass number is going to be equal to the mass of the electron, for all of the electrons, the mass of the protons, and I'm going to put plus, and then plus the mass of all the neutrons. And that's what the mass number represents. Okay, so it's all of these things put together is what the mass number represents. So if we look at another particular atom, let me erase this one, and let's say that this time we're going to take a look at the oxygen atom, which is over here. And let me go ahead and redo that, circling. And so let's say we're looking at the oxygen atom. So the amount is going to change here. So the symbol is not going to be H anymore. The symbol then becomes an O. And the amount associated with this particular, or the atomic number associated with this particular atom is going to be 8. And the mass number associated with the oxygen atom is going to be 15.9994. Okay, and so we can go and do this process for all the different atoms, and all you have to do is look at all the different elements, and all you have to do is kind of look at the respective little sections. So we can look at this one, or whichever one you choose. And each time, the atomic number is going to vary, and the symbol is going to vary for each one, as well as the mass number. So naturally, that kind of begs the question: are all the elements the same?